Hey everybody, I'm here to talk about the metric system. Yeah. Okay, well, it's not always the most exciting topic. I'm going to be honest with you. I know that. However, it's kind of the basis of doing a lot of things that we do. And so in all these lectures, I'm going to be covering, at the very, excuse me, at the very beginning, I'm going to talk about, names of metric units, the prefixes, converting from one to the other, using canceling. One thing I'm not really going to talk a lot about is how to go back and forth from English units to metric, because I mean, in all honesty, it's not really relevant for a science class. We'll do a little bit of it, but if you ever need to do this in the real world, you're just going to use Google anyway. So, and all these lectures are going to be recorded. They're going to be available for you. If you have any more questions, obviously hit me up for office hours. So, the very first thing we do is, what are metric units? And occasionally when you look this up in the internet, you may see this term SI. SI is called a System International. It's a French word. It's essentially the same thing as the metric unit. There's an incredibly small difference between them. It's not very important. So the first thing is, what do we use for metric units? And, if you know anybody who's raised not in the United States, they often look at us like, how do you not know this? Like, why are you even teaching this in college? I mean, it's like, what do you mean length is in meters? What else would it be in, right? So we use the term meter, for length, and that's important for us in this class. We'll use that occasionally. Meters. Mass, really important. We'll use kilograms. One of the differences between metric and SI is whether you're using grams or kilograms as the standard unit. You should just know how to use both and don't worry about which one is which. Time is in seconds. Obviously, you know that. Who cares about current in this class? We don't care. Temperature, we're going to use Kelvin. We also may use degrees Celsius more commonly. We are not going to use Fahrenheit. I'll talk a little bit about it in a bit, but for this class, we're just going to use Celsius. Light, not that important. And of course, moles, M-O-L-E, is the unit of amount. You may know about Avogadro's number. I'm not really going to talk about Avogadro's number very much. We'll be seeing that in some later talks, though, but very minimal emphasis. As a weird bit of trivia, the official abbreviation for mole is MOL. And the amount of time you save by not writing that E, we just wasted. Anyway, the other thing that you'll need to kind of memorize are these metric prefixes, and I'll go over these in just a second. There is one thing that we forgot to do, or you may not see here, and that is the unit of volume. We use volume a lot in chemistry classes because we're talking about the amounts of liquids and solids and that kind of stuff, and gases. It's not a fundamental unit because the volume is length times width times height, or pi r cubed, or for a sphere, or whatever it is. So it's derived from meters. So meters times meters times meters, cubic meters, and that gives you a unit. So the unit that we're going to be using a lot will be milliliters, and of course, liters. And you can abbreviate. I've seen both abbreviations, that little kind of capital L or the cursive L, either one. And we'll be using those, and I'll talk about those in just a second. Okay, so let's do the prefixes and make this a little bit bigger so we can see it. And move this down. Okay. There we go. Okay, so these are the kind of metric prefixes that you'll see. And there's a whole bunch of different ways of doing these kind of conversions, just using these prefixes and symbols, and it can be a little intimidating, but it really shouldn't be. Let me just do an example. So let's say I said you have 200 grams of something, and I said, hey, how many kilograms is that? Now, there's a couple different ways of doing these problems. You'll see, I've seen sort of on Khan Academy, which I normally think is pretty good. He has this kind of like mnemonic device, like where you memorize a little sentence about good men kick something, chickens something, and like you move an arrow back and forth. If you've ever seen it before, it's, some people say it's good. I find it weird. Let's say you want to convert from grams to kilograms. Well, we're going to see this more in dimensional analysis, but what is a gram? Well, how many grams equals a kilogram? Is it this relationship? Or is it the one on the right? Okay, well, that one's incorrect. How do you know it's wrong? Well, what do these symbols mean? So what this table is trying to tell you is that symbol K, right, means kilo. And that means 10 to the third or 1,000, or the word 1,000. You can use any of those terms. So if I say 1,000 grams, and I read that word, that's the same thing as saying 1 times 1,000 times grams. 1 times a K times grams is the same as 1,000 grams. These two things are equal. The one on the right over here, 1 gram is not equal to 1,000 times 1,000. 1,000 times 1,000, not 1. Okay. So what you need to do is you do need to memorize a couple of these terms: centi, kilo, mega, milli. Okay. So how do you set this up as a calculation? We'll be doing a lot of these little brackets, but we're going to have 1 gram on the bottom. Sorry, 1,000 grams on the bottom equals 1 kilogram. So just like this equals this, the left side of this equation equals the right side of the equation, I can put it here and I can put that there, and you multiply that out and you get 0.2 kilos. So a couple quick things about these prefixes, like where do they come from, what do they mean? The word centi, right? If you think of centi means divided by 100. So centennial is like the word for 100. So that's kind of where it comes from in English. Millennium is the word for 1,000 years is a millennium. So milli is related to that word. In computer terminology, a kilobyte and a megabyte and a gigabyte are 1,000 times. So a kilobyte is 1,000th as big as a megabyte. So there's those little steps there. If you've forgotten, your exponents, remember 10 to the minus 2 is the same thing as 1 over 10 to the second, and that's the same thing as 1 over 100. So centi, the little letter C, means 1/100th. Okay. So let me do kind of the most common mistake that you see, and I see this a lot. So if I said, let's see. So convert 250 centimeters into a meter. And again, for people who do not grown up in the United States, or if you've grown up with the metric system, this is like a pretty easy thing. By the way, just as a quick thing, a centimeter is, maybe as big as your pinky, wide as your pinky is a centimeter. 10 centimeters is the hand across. Okay. So a decimeter, which we don't use a lot, is about that big, but the unit that's not on there, DM, that's a decimeter, is 1/10 of a meter. We don't use it a lot, but it might creep up occasionally. So 1/10. Okay, so let's say you have this calculation, and I'm going to see this set up all the time, and it's going to look, it's hard for me to do this incorrectly. let's see. I will see this, which is going to be wrong. So draw a big arrow through it. I'm going to see this set up all the time. Whereas it should look like this, and that's perfectly acceptable. And there's another way of writing it, which is also perfectly acceptable. But it's not quite as common. Okay. So I got 3 different methods here, one of which is totally wrong, 2 of which are fine. And as a side note, some people will say, well, why don't you just look it up on Google? I'll just translate it. I get it. That's fine. It works pretty well. But one of the reasons you're doing these kind of metric conversions is just understanding how to use these brackets to show how to do more complex calculations. This method's really powerful, and this is kind of a nice, easy way to get started, or an easier way to get started. Okay, what's wrong with this one up here that I crossed out in red? Well, when I read this expression, to me, this person has said 100 meters equals 1 centimeter. I say that doesn't make any sense because the word 100 is not the word C. C, if I looked it up on my table or I memorized it, is 1 over 100, or 10 to the minus 2. So this part I memorize, or get it from a table, and I realize I have not set it up correctly. So the easiest logical way to always do these questions is to write it out in this form. And that's to say 1 centimeter equals 10 to the minus 2 meters. And that does make sense. So 1 centimeter is the same thing as 10 to the minus 2 meters. And that's a nice consistent way of writing it. Some people don't like to use negative exponents because, I don't know, they just seem weird. They don't know how to enter them on calculators. They're unfamiliar with them, so they don't like them. I'm going to say it's easier, but hey, So it's much more common that people write this version of that same expression, and it's also completely acceptable to do that. And I think this one's easier for a lot of people because they think to themselves 100 centimeters equals a meter. I know that because a centimeter is kind of a narrow thing. Meters about this big, 100. Oh yeah, I've seen meter sticks maybe. And that works pretty well. You should be able to do both mathematically, but if you think about this, what is 100 centimeters? Well, that's the same thing as saying 100 times 1 over 100 times meters, because the letter C means 1 over 100. So I could substitute those two. What's 100 times 1 over 100? 1. So that's equal to 1 meter. Yeah, that checks out. We have that same expression. So that's kind of how you do your basic conversions. So getting back up to the top here, we got to do a little bit of conversion. That's kind of what I just did. And I want to go volume before I hit some English units, and then we'll have done this whole short piece. Volume. You have 2 units. You have liters or milliliters, and milliliters is also called cubic centimeters, cc's, or cubic centimeters. All of these are the same. And sometimes it's confusing for people because they will see in a problem, a book will give you cubic centimeters, and they'll say, well, how do I convert that to liters or milliliters? And then not realize that this is the same thing. If you get a syringe, depending on what country it's from, sometimes it'll have milliliters and sometimes they have cc's. It seems to vary by country, manufacturers, and regions and stuff. So, whoops. There we go. Not 100% sure why people chose cc's versus cubic centimeters. Anyway, maybe it fits into the packaging better or something. It's easier to type. So what does that mean? Well, if I take a box, and if you think about what a liter is, a liter of water, could you drink that? Yes, it'd be a nice refreshing drink. A 2-liter bottle is kind of that big soda thing. A liter is like a lot. A bottle of wine is 3/4 of a liter. a Coke can is about 1/3 of a liter. So, so if I had a box of 10 centimeters by 10 centimeters by 10 centimeters, that is, not that big. My hand is about 10 centimeters across. So 10 by 10 by 10. 10 times 10 times 10 is 1,000 cubic centimeters, right? It's 10 centimeters times 10, 10 centimeters. Okay. So 10 times 10 times 10 centimeters times centimeters times centimeters. Now, if you were doing a math class and somebody told you to multiply this, right, expression. Okay, so you're in your math class. Someone says, hey, solve this. You're like, well, that's pretty easy. That's 1,000 a cubed b cubed, correct? You would all write that. Another way you might write it out is 10,000 ab cubed. And your math teacher would say, oh yeah, that's fine. You can totally do that. If you wrote this expression, your math teacher would be happy. He'd say, yeah, no problem. 10 times 10 times 10. You put the cube on the outside. It's, I think that's the distributive property. I'm not sure. But what if you wrote this in your math class? Whoops. 1,000, there we go, ab cubed. How would your math teacher react to that? I think your math teacher would tell you what. The math teacher would look at this, it's going to be a math section here. If you're in a math class, your teacher would say, God, you've messed that up because you didn't put that cube in there because you forgot to put the cube on that A symbol. And I'd say, you're right. In a math class, that's wrong. Scientists take shortcuts sometimes from math. And so rather than writing this parentheses, or rather than writing centimeters cubed, meters cubed, they cheat. And they write that. Because we do. So this is really the same thing in a science class as, that. The letter C means something. It's a symbol meaning 10 to the minus 2 or 1 over 100. It should be in there, but it's not. So your math class, and your science class are a little different here. We're doing that. Hey, sorry. So anyway, the term cubic centimeter means cubes times cubes times cubes. So that term, centimeters cubed, has another name. We call it a milliliter. And milli, of course, means 1 over 1,000. So if you think about it, if you use that letter M means 1 over 1,000, 1 over 1,000 times 1,000 is the same thing as 1. So that expression makes sense. A milliliter, 1,000 milliliters equals 1 liter because 1,000 times 1 over 1,000 equals 1. So not to add too much more math to this, right? But if I say you have 25 milliliters, how many liters is that? First of all, it's always going to be less than 1. So 25 milliliters is like a very small coffee cup, like an espresso or a shot of whiskey or something like that. And a liter is more than a wine bottle. So obviously it's going to be, the answer is going to be less than 1. So if I was going to have you convert this one, I would simply say there's 1,000 milliliters in a liter. And of course that gets you 0.025 liters. Yeah, that'll be good for liters. There's a couple more subtleties here, but generally speaking, that's the main thing. So very often in a lab situation, we measure things in milliliters. If you get a shot, you get a vaccination or something, it's going to be 1 to 2 to 5 milliliters of a liquid. Milliliters are very common in liquids in small amounts in labs. Liters a little less so. However, most of the rules that we see, most of the laws that are written are for liters. So we use milliliters really commonly. And again, so when you see the word cubic centimeters, basically just replace it with milliliters and you're going to be fine. So that's going to be mostly it for the metric system, kind of the basics. Oh yeah, English systems. Converted from English is, I used to cover this a lot more. You can look up stuff like this, 454 grams equals 1 pound, right? So I memorized that because over the years we had to, and I just use it a lot. I don't think it's really important in a science class because you're not really supposed to be using the English system. So to me, it seems kind of silly to say, well, we're not using this system, but let's spend a lot of time learning how to convert back and forth. Basically, you look these things up, and then from there, you set it up with brackets and convert back and forth. So I don't want to be doing that a lot because I think it's just basically a waste of your time. So I really want to be including a lot of those problems. Sometimes they might show up on homework questions and stuff, but I usually try to edit them out. English, homework. Oh yeah, temperature. Sorry. Temperature is the other one. There are two temperature systems that we care about. There's degrees Celsius and Kelvin. And again, for that reason, I'm not really going to talk too much about Fahrenheit. A lot of books will have you converting back and forth between Fahrenheit and Celsius. I don't think it's necessary. Like either just do it on Google or, don't use Fahrenheit. I professionally have never used Fahrenheit in my entire life. Don't use it. Just that's the easy way around this problem. All science is reported in Celsius. So a couple of things you may want to know, boiling water, just to keep this good thing in your head. Boiling water in Celsius at sea level and 1 atmosphere is around 100 degrees Celsius. Freezing water. Water freezes at 0 degrees. Obviously, ice can get colder than 0. You just have to get it colder. And to get to Kelvin, you add 273.15, if you're being picky, to that number. So 373.15. And the very coldest you can get is called absolute 0. And then, of course, not too surprisingly, 0 degrees Kelvin or minus 273. And if you're being a little weird, it's not degrees Kelvin, it's just Kelvin, and it's degrees Celsius, because strange. So why is that? We'll talk more about temperature in another time, but basically temperature is the amount of motion that a system has, the total amount of energy. And so you can't really have negative motion. That doesn't actually make any sense. So the Kelvin scale makes a lot of sense. 0 is when you have no motion, and then Kelvin measures how much motion is in the molecules and the atoms in the system. Celsius came about just based on water boiling. The people who did it originally said, let's freeze water. We'll call that 0. We'll call this temperature 100. Obviously motion doesn't cease at 0, but that's just the scale they came up with because it's really convenient for weather. You can say, oh, it's a nice day. It's 22 degrees Celsius, or it's really hot. It's like 35. Ooh, geez, it's crazy. Nobody wants to sit around saying it's 222 or 298 degrees Kelvin today. So this was done because it makes weather reports pretty simple. And Kelvin is done because it works in equations. Short answer is you should really just always use Kelvin, although, realistically speaking, when you look up science articles, they still use Celsius. But either one of those is fine. Let's never use Fahrenheit again. And makes your life a lot easier. Anyway, that's a little basic on the metric system. Hopefully that'll answer most of your questions. I'll have more talks on scientific notations, things like that. Thanks, and keep studying.